Thank you all for joining, and I hope that everything is working okay. I do want to take us today through the journey that we had with bulk data collection and why we find this very exciting and very promising also for the variety of different service providers that we are serving, and we are using these implementations in order to get them more engaged into the service intelligence era. So we all know the assumption that the service provider wants to offer more services to increase ARPU and reduce churn, right? This is the main idea for all the service providers. And we have seen the role of the service provider transitioning from their traditional responsibility, previously only limited to the edge, to the customer premise equipment, now being penetrating the home with Wi-Fi, smart home applications, home security, and other services as well. So as you are all aware, the challenges that were presented with these transitions are primarily to providing a stable and secured and a very efficient communication channel. Reduced churn is one of the main topics even today in the era, and it becomes even more relevant for the service providers as they're offering more and more managed services as altogether. But with the increase of those services and application, there is also an increase in the need of collecting data and monitoring that and getting the service intelligence. We need to provide efficient tools, not just for managing the device, but also for collecting the data and providing service intelligence. So service providers are always looking for better tools to manage control, while still one of the most important things that we must understand is that they need to ensure the quality of the experience and the overall network infrastructure and usage, and including also the service level. So the customer service experience has a direct impact on what we see as a customer satisfaction and churn. This is why CSPs need to maintain a reliable connectivity and a very high quality and stable Wi-Fi if they're offering the Wi-Fi solution. And also the ability to monitor and collect performance KPIs across various services which are building the service intelligence. So they're also looking for a proactive response based on AI and ML capabilities. We need to identify the service degradation before it happens, or at the time that it happens, in order to have a proactive resolution before the customer is actually experiencing some outage or a decrease in service level. So how can we collect all of this data? As we have grown with the number of services that we are providing to our customers, how can we efficiently collect the data without influencing the operational level that and support that the service provider is offering? This is the most important thing for most of the service providers. The provision and CPE, the provision and manage the CPEs is a crucial path in maintaining a customer satisfaction. And the main point here is that we need to balance between monitoring and collecting data while still maintaining a very high level of operational and maintenance availability. That's a crucial path with every service provider today. And this is a challenge for all service providers. So with this challenge, USP actually offers a solution with bulk data collection, and we will touch this very widely today, and we will go and deep dive with it. So let's take a closer look at the previous architecture that we had with TR69 and the approach that we had to till USP bulk data collection came. So a quick, a quick journey down memory lane. The current CPE deployment that we see, we know that the CPE supports a single ACS that he can interact and communicate with in order to send management and also events, performance events that the CPE collects. One solution that most of the service providers are taking today is the usage of a network load balancer in order to steer the traffic and distinguish between the management and operation related traffic and the monitored events. So in order to do that, we must maintain a network load balancer with a layer 7 application that could parse the information and steer the traffic based on TR69 XML, which means that we need to distinguish between some monitored events, like we all know them from TR69, which are, they could be 2 periodic and 4 value change, which indicates when a device is arriving to the system with some information that he wants to share with the ACS or a diagnostic complete. These events will be passed by the network load balancer and will be sent to a different set of collectors within the network. But we must understand that the CPE can perform only one task at a time, which means that if he's sending this information, he cannot perform the provisioning and management tasks. This is a very big downside, and we will also touch base with this during today's presentation as well. So with this network distributed architecture, the service provider achieves the goal of maintaining the separation between the management and provisional interface and the monitored interface. But there are challenges as well. The challenges are that there is a cost for this. We need to maintain a network, a layer 7 application, a load balancer in order to route the traffic accordingly. The device management platform itself, the ACS, should be aware of any change that comes, and the information should be also synced between the ACS and those servers who are collecting the QoE, the quality of experience server, which is collecting the information, because we don't want to lose those devices from the network. So there should be also a sync mechanism between them. And this actually does require additional infrastructure, servers, network elements, and so on. On the device, still the device, as I mentioned before, it can perform just one task, either provisioning or monitoring. It cannot do them at the same time. And still we have just one address that the device can communicate and work with. So how can we actually overcome this challenge, and what USP bulk data collection brings to the table here? The Broadband Forum has introduced a new approach for collecting data from the CPE. The theory of operation can be widely accessed, and it is available for everybody to use in Annex A, if I'm not mistaken, for the for TR 369, which is USP. And it is also fully compatible with a cloud integration, and I will also discuss about this in the future. So the mode of operation here actually is different than the one that we saw before. With the support of bulk data component on the CPE itself, the CPE can steer the information to the bulk data collector. That is the main approach here. This could be done over HTTP or MQTT. This will be widely discussed in this session as well. And we can specify the bulk data collector address. There could be even more than one collector according to the customer needs. He can have various collectors for various different profiles and so on. With this method, the CPE collects and transfers the events, the performance events, to the data collector. There are several methods of transport. You can use HTTP or MQTT. You can encode the data using CSV or JSON. And I know that John will touch base with that very shortly. So this approach gives us the ability to efficiently distinguish between the provisioning and management data from the monitored events that the CPE will send. And the CPE can still perform any provisioning task that is required by the controller, by the USP controller as well. And so we are getting a very efficient way of distinguishing between management, provisioning, and the monitored events. This will provide also a distributed service defined environment while maintaining a very high availability of operational service. So, and we will be able to accommodate a very high load of monitored data. This could be from a single second or a minute into which a relevant time interval that the service provider is looking for. So, and why is this so exciting for me to discuss with you today is because we actually started this conversation, I think somewhere last year, with one of the service providers that we're working with, because he had the same requirement. He was looking exactly for this kind of a solution. So what I wanted to very quickly try to show you the use case that we had to accommodate here. So let's take this following use case as an example. We had an ISP with approximately 2 million subscribers, providing high-speed fiber, Wi-Fi and mesh devices, voice services, and also TV and entertainment. So far, it is like every ISP or most of the ISPs around it. So they were looking for a better way to collect the CPE-related statistics for ONT and Wi-Fi, and they were looking to get more information on customer satisfaction and reduce Wi-Fi-related support calls. We all know that among the top-rated complaints today to the support, to customer support, is that I have a problem with my internet, right? My internet is not working, it's very slow, and so on. In most cases, the problem is related to your in-house Wi-Fi configuration, setting, interference, coverage, and so on. So this can be easily also addressed and monitored using bulk data, and I will try to describe this. So actually, he came with a requirement saying, look, I want to monitor the CPE every 15 minutes. And I want to get this amount of data, these KPIs, I want to be sent to us for every 15 minutes. What would be the best way to do that? Of course, this would be a bulk data collection. So how does this would work, in a nutshell, because I know we have a very extensive presentation today in a session to describe bulk data in more details. But in a very, a high level, I'll try to shortly explain this. Bulk data can actually be set through doing a few short steps, creating the bulk data profile, setting the collector address, setting the report encoding if you want to use CSV or JSON, setting the transport that you would like to use. It can be either HTTP or MQTT, and John will touch base with that. And then just setting the monitored parameters, which is very easy, which parameters you would like to collect. So if we are interested in Wi-Fi, and that was the main goal here, to monitor this, actually we can collect over 250 network performance measurements. And this is this was achieved due to the collaboration that we have between the Broadband Forum and the Wi-Fi Alliance device to data model that Jason described before, is constantly evolving and adding more and more object and parameters in order to monitor efficiently the Wi-Fi and other related interfaces within the CPE. So this can assist us with resolving Wi-Fi coverage issues, providing proactive tools for the CSP to identify a potential service degradation. We can collect performance metrics and show them over time. We can also create a user score based on those collected metrics, right? We can set, okay, if a user is now downgrading and his score is being reduced, maybe it would be best to have a proactive approach to check what is the use of that. Maybe he has some problems with his indoor coverage, maybe Wi-Fi interference coming from one of the neighbors, and we can change the Wi-Fi channel, for example. That would be a very simple task to execute. So assuming, apologies for some background noise here. Yes, apologies for that background noise. I think it's gone now. So this could assist us with Wi-Fi resolution and optimization. We can collect key performance indicators that are described in TR 181, and you can use them. This would not require any additional client to be onboarded on top of the CPE. You can use the same USP agent in order to continue and collect and set the CPE to collect this information and send this information to the bulk data collector itself. The indicators can be used to assess the service, the service level, the radio interference, and also assess the associated devices. You can have a better view of your indoor Wi-Fi user experience. You can also measure all of the measured Wi-Fi objects can be used to provide a full network discovery as well, to define relations between various network interfaces, if you have a mesh, an easy mesh installation within your home and so on. So there are a lot of things that we can accomplish using this, and all of this information, as I mentioned before, can be collected, monitored, analyzed for a better service. Another important measurement that we can take under consideration here is the use of CSP's compliance for speed and latency. The data can be pushed to the collector and then visualized by various applications, support tools, and even third-party BI applications. So I hope that this was, a quick journey with one of the use cases that I found that could be very interesting for the industry as well. And I will hand it over to you, John.